Hello guys, welcome and welcome back to my channel. Let us continue with our layout. It's taking a lot of time, but hey, there is no hurry, right? The thing is, get your concept and get to know what you're doing as you master your SolidWorks. And sure, we are going to also do all these items in AutoCAD. For those that don't like SolidWorks or don't have SolidWorks, we are going to do item by item in AutoCAD, right? Yes, we are done with savory, dishwash, we are done with pot wash, pastry. In pastry area, there is something that I didn't show, and we are going to incorporate it. That is the flour bin, a bin for putting your baking flour. Is it flour or flour? Whatever, man. Dry storage done, cold storage, pastry, goods receiving. Now we are in we are also done with the prep area. We are at the hot kitchen, and today we are going to be talking about the cooking range, right? The cooking range, and this is a custom-made item. You can do it as per your needs, like the one that I have here as part number D is smooth griddle, part number C is ripped griddle, part number E is a chips dump, part number F is double well deep fat fryer for the french fries or chips, and we have 6 burner low pressure and 2 burner high pressure, then an infill table here. And the outer part, this one is the extraction wood, which has pillars. It has pillars. You will see it when we start designing it. Now, how does the range look like? Well, it is slightly different from what I've shown you there. You can play around with it the way you want, and also, as we have said, it is as per your requirements, right? Now here, mine has a 3 burner high pressure. The big ones are high pressure, and a 4 burner low pressure. Then the smooth griddle, as you can see, it's smooth, and a ribbed griddle here. Then there is infill table, there is chips dump here, there is the deep fat fryer double well with the baskets, and yeah, and there you have it. And we are going to put an overshelf right into it. So can we start? Let me open SolidWorks, and as it opens, our range looks like this, right? This is in AutoCAD. The overall dimension is 2540 by 1650. You can see the 3 burner high pressure, double well fryer, chips dump, small infill, ribbed griddle, flat griddle, and 4 burner low pressure. Right, now we are going to start with the top part, and the top part that is the body. Here are the parts. I have isolated 2 parts which we are going to start with. This is the top side part and the top front part, right? And the panels, the side panels, the front panel. Then we have the structure here. So let us deal with the front side, the front part, top panel, right? And as you can see, I have a panel here of 2440, that is the size of the stainless steel sheet, and a small 100mm piece which will do a joint. If you can access the 3m by 1500 sheet, it would be okay, because you won't have a joint. You won't be required to do a joint here. Joints in stainless steel, and not, if you can avoid, it is always a very good thing. Yeah. So let me avoid this joint and go for the 3m stainless steel sheet. Now the profile goes like this. There is this part that is going to the inside, the top part, I feel like this front panel here, this part doesn't look like that, right? Doesn't look like this. I feel like this part goes like this, there, there, there. Then this is at an angle of 55, then 72. Let me mirror this. Yes. Then here we have like 15 millimeter, and if you can achieve that, that would be very nice. If you can achieve this bend, this looks ideal, you know. This doesn't look like this, so that is the profile. And also here you have another bend, a small bend here of 15 millimeter. Avoid, you know, a sharp edge. So this is 15 millimeter, this is 25, this is 50 millimeter, 72 or 75 if you want. 72 would be ideal. That will be determined by the other one. And this can be 30, so that you may have an allowance of your bending tool getting to fit in here. Then 15 millimeter. So let us start with this part, and we are going to make a sketch of this. That is 50 by 25, 40. So with your SolidWorks opened, go to the top plane, start a new sketch, center rectangle from the origin, smart dimension it. This should be 25, 40 by 50 millimeters. What's not happening here? My custom is MMG. Yes, that is good. Exit the sketch and go to base flange. The thickness of the material is 1.5 millimeter, stainless steel, grade 201, right? You don't necessarily have to do 3 or 4. You can do 3 or 4 if you want, but it's not necessary. Yeah, that looks good. So that being that, create an edge flange here of 25 millimeter, and condition blind, size is 25 millimeter. That's okay. Then another edge flange here, going to the inside. Is it inside or outside? Depends from where you are looking at it from. That is 15 millimeter. Yeah, that's good. Then another edge flange here, and condition blind, and the degree should be 55, not 90 but 55, and blind of 72. That's good. Then another edge flange going to the inside, make sure it is parallel to this face, and condition blind, and the size is 30 mil. So guys who are into bending, you know, there's one friend of mine known as Khalid from Egypt. He told me his job is to do bending. Yeah, if you can leave a comment and tell us whether this bend is achievable, right? Yeah, how you do it. It is achievable because we normally do it, but like I've been saying, I'm not into bending so much. I have a team of guys who do the bending for me. Now that is the profile. Mr. Khalid, if you happen to watch the channel from Egypt, Khalid from Egypt, I salute you very much, and thanks so much for watching my videos. Well, bring in your expertise, you know, leave a comment, tell us how you go about bending these. Is it that hectic, or do you have what tools and which bend do you do first? Is it this one, or you do the degree, or you start with this, then you do the degree? How do you do it, man? Talk to us. Leave a comment in the comment section. This is part number 1. Call it range front top. I'm saving it as front top because I will also have front panel and all that. Now, well, that being that, I need to notch, to create a notch here for the structural member. Let me do it normal. Let me create a line from here to here. That's okay. Then another on the other side, line. That's okay. Then I make this construction and the other one construction. Then I smart dimension and trim. This line here, we have said we make it construction line. Then we smart dimension. It is always very important to make sure that you do smart dimension to that, so that the size of the bend might not change when you do the trimming. This we do 51.5. No, 51 is good. 51. And also to this side, make it 51. We are going to use a square hollow section as the reinforcement member, and we gotta provide some allowance for it to, when you are inserting the structural framework, might not run into trouble. Let's see, is our workpiece good? It is good, but yes, I feel like that is good. Okay, when we are doing the assembly, we'll see whether we are good. Now we go back to part number 2, which is side top panel, and you go to top plane, create new sketch. Let us see how it looks like. This is it, and this is the profile. This is 25, this is 15, this is 50, this should be 75. So let us create this part here, which is 1420 by 50 by 90, sorry. Center rectangle. This time around it looks like that. This is 14. Is it 1420? Let me confirm. 1420, yes. 1420 by, and this is 90. 90, that's good. Sheet metal base flange, 1.5 millimeter thick. That should be good. Then we create edge flange here of 25 millimeter. 25, good. Then another edge flange going to the inside of 15 millimeter, blind 15. You can even do 10. Now we create an edge flange here of 75, blind. We will see whether it will met correctly. If need be, we are going to edit. Then you create a tab on this face. This face here, create a tab. Let's make it normal. Line from here, this side to that side, there, and that one. That's good. Smart dimension. This degree should be 55 to match with the other one, and this should be 50 millimeter to match with the other part. Then create a center line here, then select all these lines here and mirror about the construction line. That's okay. Exit the sketch. Make sure you merge the result. It is not a separate entity. Yeah, that's good. Then we create edge flange here of 30 millimeter, going to the inside, blind 30. That's good. Then you create edge flange here of 15 millimeter. 15 millimeter. That's good. Yeah, I feel like that part is good. We shall met. Save it. It's part number 2. Range side top. Let us create, start with our assembly. Some of these things you don't do all the parts then start the assembly. No, because if there are some mistakes and there are some things that you need to do editing, it is good to start your assembly so that you may start your editing right away. Met. This part is parallel to that. What's not happening again? This mates with this, that's good. Then this, not that, met this face, mates with this. Yes, now we have a problem. This being 75, this being 75, let us evaluate and see. From we measure from here to here. Normal distance is about 60, rounding it to the nearest tens, it's 60. So if we could open this and edit this edge flange here and make it not 75 but 60, then I feel like we should be good. Might be a lot of editing required there. Yes, that's good. Yeah, that's good. Yes, see here they are mating well. Now we will trim this edge flange to 30 millimeter and this one to 30 millimeter so that they may come and meet somewhere here. So we first open this and edit the edge flange. I didn't do a 45 because I knew I was going to edit this edge flange here. Normal. This I make construction and I do a line here. I can activate my smart dimension and make that, I don't want it changing from here to here. I make it 30 mil. I feel like that's good. And also same applies on the other side. I create a line here, select and make this construction line, then smart dimension it to 30 mil. Then I trim those two lines and I trim these two lines. I feel like I'm good. Exit the sketch. Yes, that's good. Go go back to the assembly and see the results of what is not happening here. Now we need to trim this other one also. There is something which is protruding here which we need to, we shall trim also that one. These are the things that you straighten with your grinder. Let us open this so that we may trim that up. Edit the sketch, edit, normal, same case just like we did in the other part. Create a line there, make this construction, activate smart dimension, we do it again on the other side. You can mirror if you want. You can create a center line and mirror, select, and this line here we make it construction. This is 30 millimeter. Then we trim that. Did we trim it? Trim that, and we trim the other side. That's good. Yeah, I feel like we are good. No, there might be something which needs to be done. Sure, you see now they are not interlocking. Well, that seems pretty nice to me. I feel like we should trim this, you know, it should not protrude. It shouldn't protrude. But when you get your flat pattern, actually, okay, let me trim it, but when you do your flat pattern, it is always very good to in the DXF file to make sure that these edges are good. Yeah, SolidWorks has an issue with there is an issue there with SolidWorks. So let me create a sketch here. I go for corner rectangle, should make it a little bit bigger. Then I take this line, make it collinear with that. Then go to feature, extrude cut through. Oh, that, don't want it, you know, protruding. And, actually I should have done something there. Let me see. Extrude cut, feature edit, blind, is it blind or both? Cut through both, see whether it will remove. Yes, I feel like that's better. Then we go for the front plane and mirror, and what we are going to mirror is that extruded cut, that cut extrude one, we mirror it. Sorry, am I opening things that are not required? We need to go to the assembly and see. Sure, right, it is not very neat, but I think that should do it. You shouldn't have. Let me evaluate and see. I evaluate from here to here. Will I get the correct normal distance? 1.68. Allow me to rembesha this thing, allow me to make it, you know, look neat. sketch, corner rectangle. No, I feel like let me leave it like that. Like that. Discard changes. Sure. Let me leave it as it is. Yeah. This part is something that you can cut with a grinder and make it flush well. Now, okay, let me first go to this part and go for that front plane. Then I mirror entities, mirror components, and the component to mirror is that. That's good. Then we go again to which other part? To front part, and we go for the right plane. Then we mirror entities, mirror, we mirror this. That is the component to mirror. Yes. Sure. Remember, there is a notch that we did of 50 millimeter here. It is to allow the structural member to fit in there. Now, with that done, and your top is taking shape, here you are going to do full welding here, full welding here, and under here you will do your full welding. It is very easy to polish these edges. You don't necessarily have to do welding here. No, don't do full welding there. It is not important, but again, it depends with how your material will met, how your parts will met during the actual assembly. So the range looks like that. The top of it looks like that. Can I give you some different views? Yes, looking at it from the right side, there is that profile. It's just for beauty, and this one is at 1990. You don't have to do, you know, a degree to this. If you do a degree, you will have all sorts of problems, right? And I hope this is not a safety hazard. Yeah, the sharp edge here is not a safety hazard for the guy that will be using the cooking range. Okay, now let us do, there is an infill here at the middle. Where is it? This one, this part, that, let me copy it, isolate it, and how is it? We are going to evaluate and see whether it is 2407 or what is the size there. Now from here to here, from here we want to create which part? Yes, we want to create this sketch. Yes, this, and this. Yeah, and that. Let me first copy that. That should be our base flange. Let me trim it. No, I shouldn't have done that. Yes, let me get the dimensions of this. That is 337. It should be 340, because in AutoCAD you normally provide the bending allowance 340. This is 60 millimeter, and the length, let us evaluate and see, because the part comes in here. Measure from here to here. What is the normal distance there? The normal distance is 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. 2363. So I go to new, then create part, click OK, top, and can I all right, let me create a center rectangle here and make it construction, make it for construction. Then I will make this 2500 by 400. There is a reason as to why I'm doing that. You don't have to worry about that. I just want to make sure my center line, my origin, is right at the middle. I'm creating a line. I create this line from here. That line should be horizontal. Yes, like this. Let me extend this line up to there. Then I will take this and this center part, shift in and make them horizontal. Then this and this, make them vertical. Yes. Then I smart dimension. We have seen this is 2363. And this should be 3. Is it 360? 360. We'll go back and confirm. 340, and this is 60, and this is from here to here. It should be 690, 680. When we are doing the mating again and inserting things there, we will change them. We said this is 320. Is it 320? Oh man, I keep forgetting. 340, 660, and 60. This should be 60 millimeter, and this should be 680. Right, then go to sheet metal, base flange. It's still 1.5 millimeter. Yes, that's good. Now we do edge flange here of 25. This also make an edge flange there, edge flange here, edge flange here, and all those edge flanges are 25 millimeters. This should face the direction, same direction. Now we want to create edge flanges of 15 millimeter here to give it strength and safety and all that. Size 15 mil or 10 millimeter all round. Again, this part is around 20, close to 20. It must be more than 2400. So still the 3 meter by 1500 sheet will be ideal for your work. Yes. Now we save this as part number 3. Call it range infill, top infill, top infill. Right, we go to our assembly and we have not saved our assembly. This is dangerous. Your work can go to waste. Island range. Now insert component, and top infill is what we want to insert. We made it. This is what is clear, this and this. Yes, mate again, this to this. I feel like there is something that needs to be edited there. Then your range should be at the middle side, that we are meeting with the infill, infill there. Yes, should be at the center. That looks good. Sure, let us evaluate and see, because this should be right around 500, something like that. 550 is good, and this should be 640 or something like that. Yeah, that's about that. And this should be what? This should be, 540, 550 is good. So range has taken shape. Save. Here again you're going to do full welding. Very easy to clean, to polish. Now let us do the dividers. And this we have seen should be, don't get tired of confirming these things. A friend of mine known as Fistek, Kevin Fistek from Chicago, when I was very new into fabrication and engineering, he was telling me, you know what, my friend, better to measure twice and cut once, right? Instead of measuring once, then doing your cutting, and you find you have wasted material. What is this? What am I trying to do? The normal distance, I'm trying to get the normal distance from here to here should be 553. So let me do 553, and we go back to our dividers. You can see they are 60 millimeters. So we go to SolidWorks, create new part, go to the top plane. We have been using top plane for so long, I'm sure it might feel a bit boring. This is 553 by 60 millimeters, right? And go to sheet metal base flange. 1.5 millimeter is okay. You can do 1.2 because there is no weight. Is there any weight? Yeah, there is weight. It will be carrying the pan support. What was that sketch? Is that sketch 50? Edge flange of 25 mil. And yes, that's good. Now create an edge flange going to the outside like that, because the pan support will be resting on this, and make this blind 20. Why does this look big? Is it 60 or 50? It looks a little bit big. Yeah, it is good. 60. Looks a little bit big to me. Discard changes. Yes. Safety, again, safety, very, very, very important. Create an amp here and double fold here. Awesome. Save this as you can call it what, but number 4A. There will be 4B for the high pressure one. Range dividers. Range low pressure dividers. That's good. Now go back to your assembly and met. Insert component. What did I do when I was saving? Typo. That flashes with that, and we met again. This part here, this mates with this, and our pan support, our yeah, for the high pressure one, met. That distance should be 3. Is it 500 by 500? Distance 500. In fact, you can do 545. That is between this face and this. Yes, that's good. Now you need to insert another one. Let me insert instead of, sorry, not this one, but the infill divider. Yes, that one. I will mate it as usual, that face to that. This to this. So we'll take a lot of time. Then this flashes with this. I can see why would and they are of the same size. What is not happening here? Is this, do you want to tell me that this line is not parallel to the other one? What is not happening? Why is this leaving a gap? It's how do you call it? Base flange. Is this not horizontal? This not horizontal? Okay. Yeah. No. Yeah, looks good. You know, that is why I normally tell you I love SolidWorks, because it is always easy to edit something. Now, this looks big to me. It was supposed to be 500. I don't know why. Why is this evaluate between this face and this is what? 540. And what is the size of this? I don't like editing it on the assembly. Yeah, this should be 540. You can edit it on the assembly if you want. It's just an habit, an old habit of mine that I kind of like editing from the part on itself, not on the assembly. Yes, now this is good. I know you will wonder, why did we do this edge flange going to this direction? Well, as you can change that or leave it at that. The pan support that you are going to do won't have any issues. It's just a 60mm gap. It will be fitting so well. Now, let us insert another part. Not that one, the divider. And we met. I know it would have been easier for us to do linear component and linear pattern, and instead of doing so many inserts, inserting and mating and all that. I don't know why, but just bear with me. I don't know why I did that advanced mate and we do with, so that it may be at the middle between this face and this other face, and I'm hoping it will be 500, otherwise we will have messed up big time between then this and this. Yes. Can we measure and see what is the distance? It should be equidistant with the first one. This and this should be what? 501, and the other one is 500, so 1mm is negligible. Then we need another infill here, not infill but divider. From that to this should be around 6 watt. Normal distance 600 is good. So I will take this, open it and save it as save and open and save it as number B, 4B. Let me correct this range and call it HP divider, HP high pressure divider. Then we take this, edit the sketch and make this 600. Yes, the beauty of SolidWorks. You know, if it was AutoCAD, by the way, one component when you are doing it with SolidWorks can take you twice as much time as to do it with AutoCAD. Yeah? Is that good English? Okay, what time you do with in SolidWorks? You're doing the same component in AutoCAD. It can take you twice as much time as you have spent in SolidWorks. But the thing is, I hate doing 3D drawings in AutoCAD. Actually, I might, in my all time of designing, I have not done more than 4 components in 3D using AutoCAD. I find it very hectic, extremely hectic. Hope you're following. Don't get carried away by the stories. We are meeting and we wanted it to be at the center there. Let us measure here and see whether it should be something like 300. Yeah, 310, 305. Yeah. In fact, we might be required to do some editing here, because should be the pan support. It's always 305 by 305 if you are using the imported one. If you are fabricating, you're good. So there we go. Now there is some infills here. We need to have what is okay. Let us evaluate and see. Measure from here to here to where? To here. We have 540. Okay, that's good. We go back to AutoCAD and see what is the size of our griddle. Our griddles should be right around 500 because they are separated. We do 500 by 500, and our chips dump, our fryer should be from here to here, should be around 600. So it's 500 and 600. So this, we are going to save it as save a copy and open, and we call it range divider 4C, range divider, we can call it sorry, griddle divider. I never release this. Let me edit this. Edit. It is 540 by, this should be 50. That's good. So we go to and insert range divider griddle. Yes, we met this. I think this is the hardest part. No, it will take us time to create this cooking range in our local language. In Kiswahili we call it what? We call it jiko, right? Yeah, you can also learn a few. Doesn't hurt to know some languages here and there. Met, and we will do a distance of 500. Should it be 500? Yeah, it should be 500. That is from here to here. 500. That will take care of the smooth griddle and the flat griddle. Now we we also insert another component, not met but insert, and we are going also to insert the griddle separator and met it from here to here. That's good. Met this, that face to this face here. That's good. Then we mate again and make sure the distance is 600 this time round to accommodate, you know, the fryer, you know, the airdrop ins, yeah, that is from here. But this griddle, we need to change something. Okay, as I go to do that, let me evaluate here and see the size. We need to get, what is this distance from here to here? It's 1163. Do I have a pencil or a pen near me? Yes, 1163. 1163. Yes, I have noted it down. Now, the chip stamp, there should be a divider. No, the divider is there. The chip stamp should be what? 310. So it's 1163 minus 310 minus 810 because of 500 of the other griddle. 1163 minus 500 plus 310, that is 810. That infill should be 353. Let me do it at 350. We'll see what we will make a bit bigger. 350. Now, as I was saying, something needs to be changed, and that should be this here. Open. Then I will be required to delete this. It's not necessary. Then this I edit, make it 15 and change the direction. They face the inside by side. Okay, that is good. Then let me first save it and save as. Copy and open. I will call it 4D range infill 2. Infill, yeah, let me call it range infill. This should be D, not CD. Then I will edit these two, edit, and change this to 350. We said 350, right? 350. That's good. Very small infill table. Do we need? Yes. Then I will edit this edge flange and add edge flanges there, and that's good. Yes, I will also be required to edit this edge flange and include an edge flange there and an edge flange here. See the beauty of SolidWorks. You don't need to do a whole new part. Yeah, you can play around with what you have to get what you want. Right, now I insert that infill table. It is part number D, range infill, and mate it. All these parts should be flashing, and this part should touch. That one. Make sure that the grid, we can make it a little bit bigger, so we because the GN container for chips dump is fixed, we make it 310. So this distance from here to here to this face, 310, right? Yes. So your top is complete, right? Your top is complete. I'm sure these are not the items that you normally give anybody to weld. You need to have a very qualified personnel who does your welding, because this is a lot of welding, because here you will do full welding, and you know something with stainless steel, you do full welding here and all these other weldings, it is very easy for this thing to start misbehaving, warping and all that. So you need an expert. They know how they do it, how to regulate the temperatures of the heating, the welding temperatures and all that, and which part to start with, followed by which other one. Not everybody. Somebody can do the welding. You do hold your parts well, you do hold the bending correct, then the welder messes you up, right? Be careful with that. Now, as I was saying, we will come and insert our banner here, and the bracket to hold the banner for the what do we call it, the high pressure and the low pressure. We will do our griddles and insert them. They are drop-ins. The GN container is an independent entity. You can have one with perforated GN container, so that, or the fat oil, what do we call it, cooking oil, the oil that comes with the chips. The idea of dumping the French fries here is for them to drain the oil, so you can do a perforated one with what do we call it, a drip tray to collect the oil. All these will be having deep trays. We will have also very small containers for collecting oil from the griddles and all that. I feel like for today we stop there and save this as part number 1. We will come and do structure as part number 2. Then we do the panels. We do the structure, the structural member for reinforcement, and it is the one which will be carrying the legs and all that. Then we will do the panels, the side panels, the front panels, and the deep trays and all the other parts. Then we'll do griddles. We will see how to do it. Okay, so for today, let us stop there. Watch out for the next video, which will be dealing with the other parts. Have yourselves a wonderful day.